Welcome. Today is day 8 of Advent of Code. I've already read the instructions. So basically, we have these antennas on the grid, and for each matching pair, like these are zeros, all are matching, and A's are matching. For within this group, for all the matching pairs, we have to find like a line that goes through both of them, like so, and mark the positions, which is the same as on both sides, which is the same as the distance between them. So for example, here is the distance 1 and 2. Sorry, 1 and 1 column and 2 rows. So on both sides we go 1 column and 2 rows, right? And you have to do this for all pairs and find the unique positions. If it's out of bounds, it's out of bounds, it doesn't count. So yeah, I've already parsed the input, as you can see. And now we can start coding. Now, first I want to find all the pairs. For that I probably should use a map. Whoopsie. Let's call it M. I think I now specify the types. I'm not sure. Just Google that. Yeah. So the key is gonna be character, and the value is gonna be an array of ints, right? And what's the problem here? Undefined character. Quick fix. Well, int, I guess. It's the same thing. Okay. Let's create it now. Now we go through the grid. And we actually need the indexes. This is going to be, let's say, an element. Okay. And now if element is not equal to a dot, you have to put it into a map. Now if m of element is probably not equal to nil, I would assume. Cannot use element variable of type rune as int value. We can make it a rune, I guess. Okay. So if it's not empty, we're gonna say element equals append m of element and the array I and j. Which has some different syntax. Okay, so we put 2, or maybe, no, we maybe could put empty and place int here and the curly braces. Can we use int value of the bin as int value in argument to append? Uh, hmm. What if we place this here and we put indexes here? Oh, I forgot the dots. All right, it's fine. So we took care of this, and now we go through all the pairs. But first, I'm gonna define n and m, which are gonna be first the length of the grid and the length of the outer side of the grid. And now we just go through all the pairs. So how do we loop through the map? Go map loop. Iterating over all the keys of a map. Okay. So we have for key and value of range m, who would have tongue. And now we just have to loop through all the values, right? Which is gonna be a nested loop, I guess. All right, so let's. How do you make a go for loop indexes? Go for loop starting at index. Oh, we can just use a normal loop. I didn't really know that. So we can use I equals 0 and I is less than length of, or we can just use n, and I plus plus. All right, now we do the same for j, which is I plus 1, j is less than m, and j plus plus. Okay. Yeah, that seems correct. And now we just calculate the distance. So distance, let's call it like that, distance I is equal to value of I of 0 minus value of j of 0. What's the problem? You cannot variable of type int. How can it be a variable of type int? And okay. So that's an integer. How can that be an integer? Oh yeah, of course. Let's just make another tab. It's gonna make this a bit clearer. Type coordinates struct. Uh, let's do it like that. And it's gonna be an array of coordinates. And we're gonna do it like that. Indexes. Can I use indexes as int values? No. Oh. Yeah. Okay. So we do it like that. Inside distance j. Oh yeah, this is I. I don't know why I put j there. Minus j dot j. Okay. So now we have the distance. Okay, and now we have to figure out in which direction we have to check. So let's make it a bit easier. Let's put A1 for antenna 1, which is going to be this, and A2 for antenna 2. I'm just going to make A1, A2, A1, A2, and now if A1 dot I is less than A2 dot I, and A1 dot J is less than A2 dot J. Do we actually have to do that? Let me just think. I'm not sure, but I think we could be fine with just maybe if we just yeah, let's try doing it like that. I think I need a set. So we're gonna need, let me just check how is it called. Antinodes, which is gonna be an array of coordinates. If so the coordinates of antinode 1 are gonna be a1.j minus distance I and a1.j minus distance j probably, and I know 2 coordinates are gonna be a2.I plus distance I and a2.j plus distance j. And then I'm just gonna append for now antinodes, antinode 1 and antinode like that. But first I have to check if antinode 1 dot I, let's just put it like that, func valid coordinates. Okay, just so it's easier. Valid coordinates, antinode 1 and m. And if valid coordinates, antinode 2 and m. Okay, I guess we don't need the key. And let me just print line the length of the antinodes. I know we have to just check if it's unique, but let's try this first. 0. Okay. Why is that? Right, we're not even getting in here. Why not? Oh, I forgot the else. Oh my god. So if the element doesn't exist, we just create it. Mm, like that. All right, now we have a problem. Line 70. Oops, why did I put N and M here? Huh. Right, 18. We just have to check for uniques now. Contains if element.I equals c.I and element.j equals c.j. Okay. And contains anti-node 1 and not contains anti-node 2, 7. Okay. Let's print it out. 8A56. Let's check this. Yeah, we have to check, but we have to check only if it's to the left or the right, I think. So if a1.j is less than a2.j, what do we have to do? We have to do it like that. But let's turn this around. It's more intuitive, I think. So like that, and if that's not true, we have to, so it's if the upper point is to the right, we have to increase the j and decrease the I. Okay. For the lower point, we have to decrease the I. No, increase the I. And decrease the j. I think so. 15, all right. So let's see. 3, 1 and 3, okay. Okay, this seems to be kind of working. There's just one edge case that's not getting accounted for. So I think it would be easier if I just okay, if contains antinodes towards ij, print, we're gonna print the hash, else we're gonna print whatever it's on the grid. Okay, and print line. Maybe I should print the string version. Okay, and let's just print the dot. Okay, so it's not really working properly. Okay, let's see. Print line. have empty notes. Alright, so 1, 8 and 2, 5 have antinodes 2, 11. No, that's not right. That's not right at all. So J here is bigger. So we go here. And it has to be a minus. And if we are to the right, yeah, we have to increase the J. It seems I messed up this one. And for the antinode 2, we have to increase the I and decrease the J. Alright, this seems more like it. 13, alright. It's still not correct though. So for 1, 8 and 2, 5, we have 0, 5. It should be 0, 11. Why 0, 5? This is fine. But then we take the 8 and do, oh, get it now. So this should be, I don't know if that will fix it, but yeah, I think it should. Oh, shit. Distance J, select 0, distance J, times equals minus 1. Still not correct. Okay. 0, 8. Why 0, 8? I'm not really sure. Oh, I misspelled this one. Okay. 14, yeah. I think we're in business right now. Yeah, that should be correct. Oh, let's just comment this out. Okay. 14, and let's comment all of this out. Okay. And if we put in the input, we get some number. And yeah, that's the correct answer, thankfully. Let's go to part 2. Oh shit. The historians ask if you took the effects of resonant harmonics into your calculation. Whoops. After updating your model, it turns out that the antinode occurs at any grid position exactly in line with at least 2 antennas of the same frequency regardless of distance. This means that some of the new antinodes will occur at the positions of each antenna. So these three T frequencies now create many antinodes. I'm not sure what that means. Oh yeah, so it just means it's increasing. Okay, that's not too bad, I guess. Uh, okay. So for part two, you just have to keep going until yeah, we just have to keep going until we reach the end. So for valid coordinates, antinode N M, if not contains antinodes 2, antinode 1, okay, we append the antinode and then we increase. So I have to use this function. Var INA diff A1 diff and A2 diff, let's say. And in this case, A1 diff is going to be minus distance I minus distance j, and in this case it's going to be distance I and distance j positive, and in this case minus distance I distance j A2 diff is going to be distance I and minus distance j. Used? Yeah, we're not using it yet, but now antinode 1 is going to be antinode 1.I 1.I plus A1.diff A1 diff.I and antinode 1.j plus A1 diff.j, and the same for antinode 2. Ah, I plus a2diff dot I antinode 2 plus j plus antidote 2 difference plus j. Okay. And this one actually goes into the next for loop, which is going to be the same, but with antinode 2 and m. If not contains, if not contains antinodes 2, antinode 2. If it doesn't contain, we're gonna append it, and then we're gonna increase its values. Okay, and then we just do print line length of antinodes 2. Let's see, 27. Is that correct? Doesn't sound correct. It should be 33. Okay, let's see. Antinodes 2. Yeah, that doesn't look correct at all. So here is minus, here is plus, here is plus, here is minus. That looks correct. One, two, three, four, five, 6, 7, 28, 29, 20, 30, 1, 2, 3, 4. Oh, switch and 10 also contains an antinode. Hmm. Let me just try inputting this example. Oh, I have to change this to a dot. Okay, let's see what happens here. 9. 1, 2, 3, 4, 5, 6. Not really sure why this happens. Oh, I have to. Why is everything minus? That's weird. Oh, so this is weird. Okay. Why is everything minus? Minus 2, minus 1, really? Zero and 5, okay. 0 and 5, okay. 0 and 5, okay. Hmm. I think we're having an issue with pointers. So let's try doing it like that. Temp equals chords, antinode 1, antinode j. Oh. Hmm. Okay. Yeah. We had an issue with pointers, it seems. Oh my god. Cool. Now that's solved. We use. Okay. Let's tidy this up a bit. Let's oh yeah, we have to also um, 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 we also have to initialize antinodes 2 array with the antennas. So what's the best way to do that? Probably here. append, or rather anti-nodes 2, auto append. We append, what are we appending? Coordinates of I and j. Let's try again. And we have 9. Okay. Great. We have another, yeah, we don't need this. And now we just put in the old test. Okay. It's 34, yeah, that's correct. And then we input my input. And we get some kind of number, okay. And yeah, that's the right answer. And we got the second gold star for day 8. Oh, all right, that was a bit longer than expected, almost an hour. But like 10 minutes was because of Go's references. So, okay, let's... Do I need to do that? I can probably just do that, right? Let's clean up the code. I mean, let's clean up the errors or warnings first. We don't need chords here. Can we do it like that? Okay. Okay, that's cool. This is for part 1, and this is for part 2. Like that. And we probably don't need that. Okay. Super great. Let's just write a quick what's happening. Oops. Ramping up. This took almost an actually more if we count input part. Think had some trouble with Go's references. Some were changed. Some reference from them. But otherwise the solution was relatively forward. Use the map to gather all connected antennas and then just did the distance and extra. Part 2. Yeah, we are slowly ramping up. Excited for the next days. Right, get add, get commit. So this is day 8, right? And let's push. And we're done for today. Thank you for watching. See you tomorrow on day 9. Bye.